Okay, welcome everyone to the January 26th, 2021 Open Planetary Virtual Lunch Talk. Today our speaker is Nahks Tr'Ehnl from Penn State, who will be talking about deploying astronomy education as video games. Thank you for being here, Nahks, and when you are ready, just take over screen share and begin talking.
Awesome, thank you.
Thank you.
Let's go. Okay, can y'all see the slides again? Okay, so yeah, thanks again to Chase and to all of you at Open Planetary for giving me the invitation to come speak about this. This is actually going to be, we have it planned as the first of a couple of talks. Today I'm going to talk primarily about how we've used the Unity game engine for game development at Penn State, and how I've also used it for some illustrations for to accompany press releases about on research projects and things like that, and also some outreach materials. The next talk in February 9th, I believe it is, will be more in depth about specifically one of our newer undergraduate astronomy courses that combines astronomy and visual arts. I'm a multimedia specialist at the Penn State Department of Astronomy and Astrophysics, and primarily I'm involved with the development and instruction or co-instruction of several of our online astronomy courses. The one that's more or less entirely video game based, we've been using since spring 2014, and it's also that, and the course I'll be talking about next time are some of the by far the largest of our undergraduate astronomy courses. Penn State happens to also be my alma mater, and I graduated around about 20 years ago with dual degrees in astronomy and visual arts. And this is, just kind of 20 years later, this is how I put those together, which is, not really what I would have guessed 20 years ago. That's what I would be doing right now. But, it's just kind of funny how life works out. It's probably that I didn't think this kind of thing would exist, but now it seems kind of obvious in retrospect to us. Just gonna go to the next slide. Here we go. So part of the motivation behind making a video game course at all was that we figured it would appeal to generations with more computer gaming experience, and we could present it like a previous course we did online in sort of a sci-fi story format, where students presumably kind of relate to the journeys of their characters. And we could introduce even some sort of philosophical topics, or what does all this have to do with me, through the characters' dialogue and things like that. We started development of what we call the University of Mars game around about 2010. I hadn't actually joined the team myself until 2012. And then the first semester we offered that game-based class was spring 2014. And since then, we've had about 30,000 Penn State students complete that course. It's more like over half of that is really just in the last 2 or 3 years, especially since we launched the new astronomy and art course. It just we've been doing this since 2014. It just turned out, we were really fortunate that when 2020 happened, we had kind of already been doing these asynchronous online classes for a few years. So at least for our small group, it didn't require a whole bunch of quick conversions of everything. So first, to give big credit where due, the concept here at Penn State of making a video game based course is really all Professor Jane Charlton's brainchild. and she's been on the faculty here over 30 years. And, has really for the longest time wanted to make a video game based class. It just happened that around about 10 years ago, Jane and Andrew Mashar, shown there as our lead programmer, discovered the Unity engine that could actually make it happen. And then I joined the team a couple of years after that. We had an earlier attempt around 2006 to make a game-based class, all based in Flash, but that would have really bit us around about a year ago when all the browsers sort of phased that out. I think if I remember Jane Charlton's original motivation, it was, or part of it was, she really just always wanted to go joyriding through the rings of Saturn and things like that, and wanted to be able to create that kind of experience that we could share with all our students. And also was very much interested in working like profound, cosmic perspective kind of philosophical discussions in with the material. So there's a lot of other folks that have assisted us over the years as well, beyond the folks on this page. We've been to game development conferences, Unity engine workshops, and things like that. And of course, our core team has usually been about 4 people on the team at once. And as we're playtesting things, it usually works for us, or at least we kind of know where we mean to go all the time. When you let that loose to classes of several hundred or even thousands of students, then you quickly find where all the bugs are. So I have to give a shout out to our students as well for helping us, iron out the wrinkles in the program here and there over the years. So here's just a quick movie of what this video game looks like, and this thing's going to blow by really quickly. This is vastly accelerated from what the actual gameplay is like, but just to give a sense of how a student sort of starts out, creates an avatar, a nickname, and then actually walks around this little 3D world, can interact with other characters, use vehicles and things like that. And it starts out exploring our speculative semi-near future Mars colony, and beginning with sort of classic astronomy concepts, backyard astronomy kind of things. It moves on ahead to topics in basically a virtual tour of the solar system, and that'll come up in just a few seconds here. And then with each of the main 4 units in the course, it sort of goes up like an order of magnitude in spatial and I guess temporal scale as well. Here's just a sense of some of the kinds of in-game activities that there are. Some of it involves exploring the surface of Mercury and that little part, flying around Venus, the moon, and also things that have to do with plotting data, fitting curves, and some calculations and things like that. Over time, we've been able to add new parts to this. Like I said, it's was first launched in spring of 2014, which was before, say, New Horizons went by Pluto and got a lot of the best close-up scenes, shots. So that was a part of the game we could add to it after that happened. And just other, new discoveries, science results, and things like that, as well as just general gameplay refinements. The original version of the game, for instance, had this Mars colony that was all this like network of little clear tubes and things, and the characters could only walk from one place to another. Of course, we got a lot of feedback from students saying, hey, can the characters at least run, or can you have like a mini map and do fast travel from one location to another like Skyrim? So, eventually we got to adding those kinds of things, as well as having the game linked to an online database we set up. So we could actually, as the instructors, we could actually track their progress through it and their scores on like the in-game quizzes and things like that, so that we no longer had to ask our students to like turn in their save file to us by email or something. It could just sort of work automatically. So here's just a couple example scenes of some of the sections, constellations, little fly through around Titan, picking apart the layers of the sun's matching spectra of stars, and studying galaxy types and all the contents thereof. This is just a quick look at sort of the Unity interface, and I don't know if you can use like the Zoom reactions to give me a quick sort of show of hands of who here has actually used Unity before. Chase, you mentioned Zoe had, um, or other game engines like Unreal or something like that. Um, yeah, I'm now I'm primarily a visual artist sort of contributor to these projects. I've only in the last few years begun to learn more of the programming aspects. We've had a few lead programmers over the years that handle most of the script tying together the scenes in the game and the dialogue and things like that. Um, but I've had a lot to do with constructing game worlds, like this one, for example, is one of those neat places where we can actually gather data from NASA's missions, like Messenger's maps of the surface of Mercury, and recreate those little sections of worlds in Unity. So this is actually based on topographic data from Mercury's North Pole, and there's a section in the game where you have a mission to go check out what the bottom of one of these permanently shadowed craters. So I could recreate, not to scale once you put the player in there, but recreate an actual scene, and we can describe it as such in the game. We've had to go through several Unity versions over the years. Back when I joined the project in 2012, it was Unity 3. And at the time, we had to borrow a lot of third-party assets through the Unity Asset Store for things like a dialogue and an inventory engine. And a lot of our mini games, it's kind of a collection of mini games, each one sort of discusses or breaks down a specific topic lesson in astronomy. And a lot of our mini games have been things that we sort of made each one up on its own along the way. Now that we've had this program in development for several years, I'm going back and trying to sort of unify our design between several lessons to basically to kind of reuse assets like scenes and 3D models and things like that, so that one lesson blends a little more logically into the next and builds up on the player's end. Using things that they've been steadily becoming familiar with. This example in the slide here is actually just pretty much a direct recreation of what used to be a Flash-based thing developed in the University of Nebraska Lincoln, and they had a whole site full of really awesome like Flash-based little simulators and interactive things, and we used to borrow a lot of those in our astronomy classes, but since that's basically out of service as of the end of last year, we've started remaking some of those. So I don't, if you remember the set of Flash things that I'm referring to, one of them had it was a demonstration of the inverse square law, and it had two light bulbs and a couple of lenses as detectors. I basically rebuilt the same thing using Unity with some stars and little Hubble telescopes and stuff like that. So to basically guide our students through the same lesson. But what's neat about this is Unity can also build to HTML5 and WebGL. So a sufficiently small, low performance load mini game like this can be hosted in a website. And we can make a whole lot of these things. And aside from them being components in our overall game, they could also be standalone things that, any instructor could drop into their class however they wish. This is another mini game we built, and I'll go into a little more detail about this in the next talk because we use it in the astronomy and art course. But it's a sort of guided lab-like kind of exercise where they start with finding a known extrasolar planet in the NASA exoplanets catalog. That's the image on the top left. And then you use a program we made to actually take some data for whichever planet and star they pick out, and so try to like recreate that planet with a lot of artistic license applied to the appearances, and a number of just sort of open-ended customization options, like adding a ring, or how many moons or what kind of surface you want. The idea is to have them explain why they make each choice. I made it an ice-covered world because it's beyond the habitable zone for that star, and things like that. And we can also use these mini games in our outreach activities. So Chase is familiar with this, but at Penn State main campus for the last well over 20 years, we've been doing our Astrofest big summer open house event, and it's been coincident with the Central Pennsylvania Arts Festival. But for the first 20 years, we started in 1999. For the first 20 years, it was an in-person event held over 4 evenings in mid-July as the arts festival is going on, and we draw anywhere from 1,500 to 2,000 visitors each year. Then 2020 happened, and the arts festival went to a sort of virtual format, and we too canceled our usual event and made a virtual lobby. So I constructed this little scene where there's like an arcade corner. Our visitors could walk into this virtual lobby, go over and find links to any of a number of mini games in astronomy, or links to a number of either recorded or live talks. And sort of our, instead of having our free public stargazing with our telescopes out in the street or up on the roof of our building, I had, a little virtual observatory where if you click on a particular exhibit, it would take you to the Stellarium online page where, with the settings for the location of University Park and the date and the time and the view of certain objects. So it was kind of an interesting challenge to kind of come up with a way to recreate all the things that we usually do at an in-person Astrofest. But another advantage of this one is that when at the end of July, the program doesn't have to shut down. This thing can remain online, and you can check it out at the link at the bottom there, or just look up Penn State Astrofest. So this kind of event can just stay available all year, and then we can add new program components year after year. This is first of a couple of things I've done with what became like illustrations to accompany presentations. This was some work for our Dr. Neil Brandt at Penn State on discussing these sort of transient arcs of charged particles erupting from an accretion disk around a active galactic nucleus, with sort of being more active near the center. This thing, the funny thing about this, and there's another example I'll show in a sec, is that it started out as a digital painting. He just wanted a still image to drop into a presentation slide. But we went through so many iterations and revisions of that digital illustration that I thought, well, rather than having to like redraw discs and this and that and so forth, I could just model it in Unity, and then just tweak the colors, scales, and lighting effects and things like that there much more easily than having to hand redraw things. And also, and as a bonus, oh, by the way, make it animated. So Dr. Brandt got into this too, and it's sort of moving forward, like to add sort of a camera or flight control, so you can kind of take control and zoom in and around the scene. And maybe also work in some like wavelength filter uh, visual modes. So it might mean applying alternate materials or textures to the objects in the scene. And eventually, there's not really any physics built into this. It's just mostly for appearances. But eventually, the newer Unity versions have introduced like force fields for particle systems, and I'd like to play with those and actually model it after Dr. Brandt's theoretical work, in a little more robust way. The next case was another one that started out like the pictures in the upper right as just drawings meant to try and illustrate the geometry of a couple of pulsar systems. It was work for Dr. Betten Apostle a few years ago. From at the upper left, some Chandra X-ray images. And so trying to puzzle out, what's going on with these pulsars with jets in sort of, either passing through like the interstellar medium and having like this ram pressure or this bowing effect to the streams. Again, it was another one that this was actually published with the digital paintings first. But after doing the work with Neil Brandt, I thought, oh, I could go back and play with particle systems in this too in Unity, and actually, maybe work in control so you can sort of pan around the scene and in 3D kind of understand, why these objects have the appearance they do, just from our point of view. This is more work with Betna and her collaborators on pulsar systems that had kind of an infrared excess. So I helped illustrate in 3D animated some of the proposed scenarios to explain these. So one was a diffuse nebula that the pulsar system is traveling through, or possibly a debris disk at a low angle. So there's like this glint coming off of it, or it's kind of hard to see, but on the upper right, having a swarm of small bodies like a Kuiper belt or an Oort cloud analog that some of the light is diffused around and coming to us in the infrared. Kind of looking ahead to upcoming projects, this summer I'll be working with Dr. Radici and an undergrad we've hired who's also an astronomer, also studying art. And we intend to build a sort of virtual reality, actually immersive VR simulation of light behavior in the vicinity of a black hole. And Dr. Radici wants us to, actually recreate robustly the physics involved in this with the ray tracing. Again, that kind of programming in physics is sort of outside my experience, but I expect I'll be contributing just some general like textures, materials, and 3D models and things to that. And also, we have another online astronomy course in the works, which is sort of a follow-on to the Astro 101 that we do, that's more in-depth on the topic of the Big Bang and cosmology. And Dr. Jane Charlton again, and our Dr. Anna Makovich and Tim Snyder, our programmer. They're leading like the game design, the story elements, but I think at least one thing it's going to include is a whole game about, it's kind of a race against time to visit key locations around the universe before universe expansion puts them out of reach. So it's kind of a different kind of game than what we've created so far, and I'm looking forward to working on that. So I know I'm coming up near on the allotted time, but I did have a couple of the Unity projects kind of available if anyone in questions would like to like for me to sort of demo what it looks like in the Unity development itself too. I could show how some of these things are assembled. So I guess at this point, happy to take any questions.